Okay, well, I think we've got a quorum here. Welcome, everybody. My name's Emer Dooley. I'm at the Foster School of Business, and I want to, first of all, welcome and thank Matt Hall. We'll go to you just in a second, Matt, who's VP at NVIDIA, so we're excited to have him. So the speaker series is designed to bring together, AI industry experts and thought leaders to share insights that will inform the UW community as we start to try and integrate new technologies here at the academic, medical, and business systems. So obviously AI is having an enormous impact, which is what we're going to talk about today. We want to get, really diverse perspectives, both clinical and supportive, both critical, I should say, and supportive. I doubt very much that either of us, Matt or I, are in the AI critic camp at the moment. But it's really important that we as a community really understand this. So I'm going to start with a few questions, and then I'm going to open it up to the audience. This is going to be way more fun if you're not just listening to the two of us. Please send your questions to townhall@uw.edu, and that is in the chat. So first of all, Matt, thank you so much for joining us. Maybe you can give us a little bit of background on yourself. But what I'd love you to do is almost like draw a parallel to the evolution of the computer industry as you do that, because now you're part of one of the most transformational companies there is.
Yeah, absolutely. So first and foremost, thank you for having me. It's a pleasure to be here. I have a very special place in my heart for UW and for the Foster School. I'm an alum from 2010. I think it was the Technology Management MBA class of 10. So it's good to be back. So Matt Hall, I live in the San Francisco Bay Area, back in the Bay Area after spending 15 years or so in lovely Washington. I've been in tech my whole career. I started out in the storage side of technology, working for a company called Seagate. And we were doing data storage on hard drives, and that industry has evolved quite a bit. I was there about 7 years and had some very interesting engagements, helped a small company called Google figure out how they were going to store all their data. I worked with a company called Microsoft building something called an Xbox and figured out how they were going to store the data for the Xbox, and then decided to go deeper into the technology beyond just the storage. So I went to Hewlett Packard Enterprise. I was there for about a decade, working with Microsoft on Amazon on how to build out infrastructure for Red Dog, which became Microsoft Azure and AWS. And then continued my career at HP in a number of different facets, ran some product teams, ran some engineering teams. And then 7.5 years ago, I joined this company called NVIDIA. And it's funny that you say, Emer, that everybody knows NVIDIA now, and it's this big behemoth. But I'll tell you, 7.5 years ago when I joined, I had to spell NVIDIA and explain NVIDIA and define artificial intelligence for anybody I talk to. So in the 7 years I've been here at NVIDIA, my job is global AI solutions go to market. And what that really means is democratizing artificial intelligence, taking the power of the compute and the data and turning it into full solutions that we can roll into enterprises all over the world for healthcare or automotive or financial services. So the journey I've been on is, like you said, very similar to the journey of the IT industry, really pieces and parts rolling into full solutions and cloud solutions, and then rolling into now this really fast compute and massive amounts of data that's brought us to the age of AI.
Yeah, oh, well, we can talk about AGI and ASI, but so one thing I should quickly introduce myself, Emer Dooley. I run an organization called Creative Destruction Lab, and what we are is we're a deep tech accelerator at the University of Washington in two areas. One is computational health, which is computing to change the future of health or medicine, and the other one is in industrial AI or advanced manufacturing, and that is computing to change the future of manufacturing. So I'd love to ask you, Matt, what industries, let's start out with a little bit of the general, and then we'll get more into some of the specifics of what NVIDIA is doing. But what industries are you seeing the fastest adoption of AI in, and what are the laggards?
Every industry is now adopting AI. We did a press release and a story with Domino's Pizza, I think it was last year. And I realized that if we're innovating around pizza, then we've made it pretty pervasive. The fastest adoption and biggest adoption to date has probably been in the medical pharmaceutical side of things. Financial services, we're starting to see a huge acceleration of manufacturing and retail. But like I said, every single industry is realizing they need to grasp the power of artificial intelligence. So I don't think you're going to see an industry that doesn't have a dozen or so use cases at least and isn't innovating.
Yeah, and I think one of the things that's getting everybody is the speed at which this is happening. Because literally 4 years ago, I had the CTO to pick up on your medical and of one of the big biotechs here say that the bio industry has no concept of the extent of their machine learning problem. And 3 years later, that's just no longer the case. Like absolutely not the case. I mean, in fact, the market's moving so quickly, right? We're starting to see parts of it consolidate already. You could say that the model piece is consolidating. So as somebody who works with early stage startups, what are the areas you see the most opportunities for startup companies to really innovate here?
Yeah, so maybe I'll take a step back just to kind of define the journey and how we've gotten here. AI is nothing new. AI has been around since the 1950s, Alan Turing test, as you're well aware, but harnessing the power of AI has been really difficult, right? There's been science fiction books written about it, and then we had a Big Blue with Gary Kasparov, or what I think was Big Blue, something blue, the IBM machine. Why we're here today is because we have more data than we've ever had. We have the ability to compartmentalize and do things with the data that we haven't done before. And we have compute power like we've never seen, the parallel computing. So at its core, the way I explained it to my 10-year-old daughter, AI is taking lots of data, computing it very quickly, and applying math to the process. The underlying process across all industries is really the same. I mean, it's a very horizontal focus play at the IT infrastructure, at the way you move the data. The magic that's industry focused and specialized is done on top of what we call this AI factory, which is fairly generic. I think startups, we've seen a huge boom in folks that are building large foundational models over the past few years. The advent of ChatGPT. I think the things that are going to drive us into the future are really around the inference, right? So you now have these large trained models. Now what do you do with it?
And just in case there are people here, can you explain what you mean by inference?
Yeah. So similar to school, you get trained. Maybe you take 4 years of high school or 4 years of high school plus 4 years of college. Maybe you go for a doctorate, and then the rest of your life is pretty much inferring. And you're checking back into the training to make sure you're keeping up. But you go out, you train this model, you train an AI model with lots and lots of data and lots of parameters. These are multi-billion parameter models that take months to train, even on the new technology that we have in the industry today. Once those models are trained, you infer against the model. You go out and say, okay, I learned that this was a dog, that's a cat, that's a squirrel, and you can now infer, if you're a self-driving car, what the animal is. So we've spent a lot of time on training these models. We've seen the outputs. Now the inference is going to be the big part of the industry moving forward.
Yeah. So, but maybe it's kind of modesty on your end, but you didn't talk about there like why NVIDIA was so transformational. And I think, in a lot of cases, people think of NVIDIA as a chip company. And, I like to think, well, it's anything but, because that's not what differentiated you. So maybe you can talk about why you're in such a kind of catbird seat at the moment.
Yeah, absolutely. We are a chip company, but we're also a lot more. We build chips. The dirty secret is NVIDIA has been around for over 30 years. We were founded in 1983. And most people know us. Most of the people that knew us when I joined were under the age of 25. They were all gamers. NVIDIA was very successful at making what we call GPUs, graphics processing units. And the graphics processing unit is very different than an x86, like an Intel chip or an AMD chip. In the fact that an x86 chip has very large workloads going through in a serial way. So one job, then another job, then another job. What the GPU did for graphics was it allowed for parallel processing. So they were smaller cores, but you could have lots of jobs running through the chip at one time. The realization over a decade ago was this is the way the brain works. This is the way we think. And that this type of technology and compute power is perfect for artificial intelligence. So it started with a chip. The realization beyond the chip, though, was you can't do much with just the chip. You need to store the data. You need to move the data. You need to have the software that allows you to extract value from the data. So NVIDIA has grown from a chip-focused company to really a full-stack AI solutions company. We own the networking that moves the data between the chip and other places. We have massive libraries of software. We have more software engineers at our company than we do hardware engineers. And we have really focused on building full stack solutions instead of just providing a single component. I liken it to the iPhone, right? If you build the entire thing to work together, the software, the hardware, all of the pieces, you're going to get much better performance if you're just taking off the shelf parts and trying to put together in bespoke ways.
Yeah. And so I think one of the things, like this, one of the areas of your sort of expertise and what you do, is very much around DGX, your DGX and GGX cloud platform. And maybe you could explain a little bit about why that matters. And then, tell me why that does not put you in competition, because I just saw a video of you recently and you said that, you do two things. You sell the ingredients so people can make their own thing, or you can, build your own solutions like DGX Cloud. How does that not have you competing with your biggest customers, Amazon, Microsoft, all those?
Yeah, those are great questions. So to go backwards, DGX was a product. We launched something called DGX One the year before I joined NVIDIA. And DGX One was taking our compute, a chip, and putting it into a compute appliance. The first unit that we delivered, our CEO Jensen hand-delivered to Elon Musk at a company called OpenAI. I came on board to drive the business, and the realization, like I said, was we had done a great job of taking this chip and turning it into a compute appliance. But no, all we had was a compute appliance. We need the data to come in and out of it. We need to store the data. We need the software to make this work. So the journey we've been on, like I said, is to really make sure that we have all of the layers of the onion, I like to think about, with compute being at the middle, the data movement, how do you interconnect all of the various components, how do you manage them with software. The data centers are becoming really, really important now, right? All of this compute needs to live somewhere. It draws power. It needs to be cooled. So we started looking at how do we deliver this at the data center scale, both physically and as a service through DGX Cloud. We now talk about AI factories. So it used to be we would talk about a chip, then we talked about an appliance, and now if you hear our CEO, we have our big conference next week, so please sign up for it, GTC, watch it virtually. When we talk about AI factories, AI factories are the entire building, the data center with all of the compute. That's really the new increment of compute. It's the full data center. It's not an individual chip. It's not a system. So we deliver it physically and we deliver it as a cloud service. The idea is that we want our partners to deliver this. Our partners being Amazon and Microsoft or Dell and HPE. But we want to show them the best way to do it. So it's kind of like we have an experimental kitchen. I used to be a chef in college, and we go in and we experiment in the kitchen and we figure out what tastes good, what doesn't taste good. And then we serve it to our internal customers and say, what do you think? And they say, well, it needs a little more salt. It needs a little bit of this. And once we define the perfect recipe, we publish it and we say, hey, here's the recipe. Oh, and for reference, here's what it looks like and tastes like in the DGX line.
And so, I've seen, Jensen Huang talk about, the new unit of computing is the data center. Give us a concept of, some of the biggest ones you've seen. XAI, for instance, kind of went from 0 to over 100,000 GPUs. What's the scale of these and how much do they cost?
Yeah, they're getting bigger and bigger and bigger. OpenAI was a fantastic one. They, as you astutely point out, deployed 100,000 GPUs. They did it in a very short period of time. And now they're talking about their next deployment, right? The more GPUs, the more processing power you have, the more artificial intelligence you can build and get done. I think we're on the precipice of many 100,000 GPU plus data centers being built. We're looking at sovereign AI. We're looking at countries that are saying, hey, we want to have our own AI models. We want to have our own AI supercomputers, and we're going to invest at the scale of building these massive data centers. We're seeing states, university systems starting to do the same. Project in New York called Empire AI, where 5 of the largest universities there banded together, and they're going to build a very large cluster for AI for acceleration of their academia in New York. We're seeing it in other states. We're seeing companies start to deploy these things at very large scale. So I think 100,000 GPUs is going to be a drop in the bucket in a couple of years from now.
But how much does it cost to do something like, say, the 100,000 GPU center? I think people are really curious.
Yeah, you're getting into the billions of dollars for sure.
Yeah. And so you also brought up a really interesting comment, of universities deploying these, universities getting together as sort of research units. The University of Washington is looking at, building sort of a GPU core. How would you talk people who are making those decisions, many of whom I'm betting around this call, and get your questions in? How do you talk them through, the pros and cons of on-prem versus in the cloud, and the obsolescence that you want to think about if you're building it yourself? How do you think about that?
Yo, fantastic question. That's a conversation I have, seems hourly now with CIOs and others around the world. Let's talk about on-prem versus cloud. What people are realizing is they want control over these AI models. They want the AI work to be done where their data lives. And many times that's not in the public cloud, and they want control. So many folks are choosing to do this on-prem. One of the reasons that folks are now looking to do on-prem is they realize that they can keep these things utilized at a very high rate. It used to be, back when ChatGPT a couple of years ago happened, industries were saying, we see a use case. We see one use case, and we can go do it in the cloud real quick, and then we go off and do it. Now what these entities are seeing is there's not just one use case, there's 100 or 200 different use cases. So back to using my food analogy, which I use a lot as a prior chef, instead of going and grabbing takeout because you're just going to eat one burger, now you're being asked to cook many, 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 many different things. So now you need to build a big kitchen, and that's a shared kitchen that can produce a lot of different things. With that said, there is a massive opportunity for the cloud. So I don't think it's an on-prem or cloud, it's an on-prem and cloud. You have your kitchen to build the things that you need to build on a regular basis that you're going to keep occupied, but when you can't, you don't have enough capacity in that kitchen to keep going, when you need a bigger blender or whatever it may be, you burst out to the cloud for some workloads, right? And then the unspoken thing is going even beyond the on-prem out to the edge when you start thinking about robots and cars, right?
Yeah, but one of the things that NVIDIA says is like they almost like guarantee backward compatibility, so that if we do say invest in a 200 H or 200 by H100 pool, the things will continue to work, but we will have to, at the rate things are going, it seems like a very difficult decision to actually buy into the infrastructure even required to house something like that.
People are realizing is this inference explosion that's about to happen. You're going to need infrastructure to do inference. And there's a lot of startup companies out there. There's a lot of companies that have been around quite some time that claim to have incredible inference solutions. What a lot of our customers are realizing as we launch our next generation NVIDIA stuff, you already have an install base of stuff that's probably depreciated. It may be paid off. So you take that infrastructure, you repurpose it for inference, you bring in the next cutting edge thing for training, and it becomes this flywheel. So it's not like if you purchase our infrastructure and then the next thing comes out, you've wasted money or you've missed out. You're actually taking the ability to repurpose it for the next thing. It's kind of like when you go buy a new car and then you give your kids your used car, then you go buy a new car, right? There's a useful use for the stuff you already had.
Oh, Matt, come on, you make you make this pitch, I think, every day. So, um, uh, how do you talk people through making those decisions? Because the right now, it's fine if you're already on sort of NVIDIA hardware, but your sales are what, 160 billion a year. That's small because the estimates of the install base for data centers out there right now is over 1 trillion. That's a lot of market share for you to gobble up. Who else is out there who's capable of doing this?
Quite frankly, there's not a lot of people, not a lot of companies. And it's because our company, our CEOs had the forethought to think about us as a full stack factory. There's a lot of people out there that are building chips, and many of their chips may be better than NVIDIA's chips. I don't know. There's people out there that are building network, they're building software, but nobody's building it to work together the way that we're doing it. And that's why we've gotten so much press lately. That's why we've been at the forefront, because we've had that way of thinking. I'm sure there's others that are going to, think in the same way, but we have a big head start. You mentioned the data center TAM, the total available market. We're seeing more and more workloads getting accelerated on our GPUs, and we're seeing more and more data centers being built. If you guys are interested, the administration announced something called Stargate, which is the massive supercomputer, $500 billion investment the US is making. If you go on the internet and you search for the data center that Stargate's going into, you can see how fast these new data centers are going up. So the install base for data centers today is going to be very small compared to what we see in the future.
Yeah. And I mean, and for people, we're talking about, the reason we're talking about more or less this obsolescence and, Matt, you can correct me, but, we've really, moved from, a system of sort of CPUs to GPUs and, from traditional applications to AI-driven applications and, really from software programming to sort of, machine learning models and AI on top of that, right? It's really a fundamental shift that maybe you can explain to us because, you say that the company is 30 years old. And the real realization of sort of parallelism and why NVIDIA could power these things was probably AlexNet in 2012 or whatever. Between then and when you joined the company, that was almost like your incubation period, and so it's been a long time coming. What happened 2 years ago, and why did it all explode?
So ChatGPT became a wake-up call for a lot of folks. It wasn't a surprise for many of us on the inside. Many of the people watching probably saw what was happening, but the people that weren't attuned to what was happening in the world of AI finally could write a haiku or do things that they never thought possible. My daughter did a lot of poems about unicorns and all these wonderful things, but it woke people up to what was possible. So we had this generative AI boom over the past 2 years. And generative AI is simply when the AI model can generate things, whether it's pictures or haikus or whatever it may be. The next trend that we're seeing front and center is what we call agentic AI. So instead of these models just developing what we've asked them to develop, they can actually reason and think. Okay? So you're going to have these AI agents embedded all over the place that can help you get your work done, whether you're in the healthcare profession, customer service. The next step after that, which is where we're pivoting to and we're moving so quickly, is physical AI. So how do you take this AI out of the data center, out of the computer, and put it out into the wild? And that's where we're going to see robotics. And those robotics are going to be in the form of self-driving cars, robots performing surgery, and actually physical humanoid robots, which is something we're investing quite a bit of money in.
Yeah. And I mean, I think one of the cooler things that you're doing is maybe you could talk a little bit about the robotic space, what you're seeing. And, I always thought like 2 years ago, one of the biggest problems with robotics was, it's destructive testing, right? To learn, you got to go out and bump into things. But with your creation of the Omniverse and Cosmos, that's changed. So what's fundamentally different about that? And what does that mean for computing on the edge?
Yeah, great questions. Obviously done your research. I like it with Omniverse. So two things. Number one, we realize that AI has to come out of the computer. It has to go into the world to help. The way it has to go into the world is through robots. Those robots are going to vary in form factor, right? Right now up in Seattle, Amazon factories have robots running all over. We have robots that are building cars all over the place. But most of the world's data is built around human data. So the realization is if we're going to go train robots with the data that we have, it's probably best to have robots that are like humans, 5 foot to 6 foot tall, weighing a certain, and it'll be easier for us to take this data and adopt it into a way that these robots can actually be useful. To your point about it being destructive, yes, there are many videos out there of robots failing and things not going well, or factories where they've developed these things, they deploy them and they don't work. So for those that are not familiar with Omniverse and some of the things we're doing, we're actually developing physical replicas, or I'm sorry, replicas digitally of physical worlds. And in those digital replicas, you can test things. You can figure out the distance of things. If a robot bends over, what's going to happen? If this happens, then this happens. And it allows you to test out everything you're doing in a virtual world before you deploy it physically. We can train virtual robots in a virtual world, and then that training can go into a robot in the real world, and they can infer based upon what was trained in the virtual world. One of the things, the first instances that we started using, the first use case was, oh, did I lose you?
No.
Okay, screen froze here. First instance was automotive. So self-driving cars has been something that everybody has been hoping for some time. But to get to a point where regulatory authorities would approve self-driving cars, you need to have billions, if not trillions, of hours of data that you can train these models on. Well, sending out that many cars into the wild is impossible. So through our virtual simulation technology, we created virtual worlds that these virtual cars would drive through and experience different situations. So you could train your models for self-driving cars, not just on the physical cars, but in these virtual worlds, and it creates these much better models that we can infer against, if that makes sense.
Cool. Yeah. What could possibly go wrong, right? Yeah, a friend who works at Tesla, and they say for all the billions of hours they have of Teslas saving people's lives and making the right decisions, the only one obviously that's going to make the news is when they don't.
The interesting thing,
yeah,
I've heard a lot of folks say in the industry is
so I wanted to maybe ask one or two last questions and then hand it over to the audience for questions. Maybe we can do a very quick, like when do we see, AGI or ASI? Like just real quick questions.
A lot of different theories. I think it's sooner than most people think, but I don't want to define that as 2 months or 20 years. I don't know. It's coming quickly.
And yeah, there's kind of like the speed around here. Like, AI, what's your take? I know what Jensen's is, but, should it be open or closed? Pros and cons.
Open, 100% open.
Why?
I think it allows for innovation. It allows for safety. I think it's a pretty dystopian world if you have 1 or 2 AI models in the world, right? I think most entities want AI that's germane to their domain-specific information. So you don't want to take off-the-shelf AI that is closed. You want it to be something that you can tailor to your own use case. So open is what we're fully behind, democratizing AI.
Okay, so there's a bunch of audience questions. Jared, do I just read them out, or like the first one, of course, is DeepSeek. What do you think of DeepSeek? Was it really trained inexpensively? Is it as revolutionary as people are saying?
So, no, it wasn't trained as cheaply as people think. They forgot a lot of the pre-training and a lot of the other things that they had done in their analysis. With that said, I think it's a great thing. We want these AI models to be more efficient. We want competition. We want there to be this faster cycle time and ability to do it cheaper. It's the only way that AI is going to evolve, if we can do it cheaper and faster. So overall, it's a great thing. I think there was some red herrings there that weren't 100% true. but it got attention to the need to do things faster, cheaper.
There's another question about resource constraints and limiting factors. Given the demand for AI and data centers right now, what's the biggest constraint from a resource perspective? Electricity, raw materials, or semiconductors?
Yes, yes, and yes.
I knew you were going to say that. It was like when I said cloud or data. Come on, we're going to nail you on one of these, Matt.
Yeah, I think long term, power is going to be one of the most restrictive. Um, we're making our chips and our systems more energy efficient every generation. So each chip that we launch replaces, hundreds of last generation chips. So it's becoming more energy efficient, but because the demand is so high, there's going to be energy constraints. And there's so much innovation happening out there around energy generation.
Hey, we
Like
have 5 fusion companies in the Washington area.
fusion, I toured a hydrogen powered data center 2 weeks ago.
Where?
Um, here in the Bay Area, and they're going to be deploying some very large data centers in Texas. We're looking at all different types of new power sources to keep this stuff going. Beyond power, there's all these things that you need to build a data center, whether it's chillers or cabling and all those things. So we're very cognizant to make sure that everything downstream has supply.
Yeah. So there's a question here about quantum, data access and bandwidth, given the exponential increases in processing by technologies like quantum computing, what are the challenges you see in enabling access to, data at scale?
Yeah, so let me talk about quantum computing. Our company and our CEO made headlines, not in a good way. He was asked when quantum computing was going to become real, and he said something like 10 years. And all of the quantum computing stocks crashed. So he's been apologetic. And actually, next week, we're having a special.
Next CEO saying something that makes the market crash? Yeah.
But no, quantum is going to be extremely important. It's going to be extremely transformational. We've been spending a lot of time on quantum, but it's something that's a little bit out. And with the way things are going over the next year or two, we really need to stay focused on what we're doing. The question I think was about data, and everything we're doing is around data. Access to data, curation of data, the cleansing of data, the processing of data. In the future, let's take a self-driving car, for example, right? You're going to want data that is stored and processed in the car. You're going to want it stored and processed somewhere close to the car, at a light pole on a highway. Then you're going to want it stored and processed at a small data center somewhere, and then all the way back to the cloud. So you're going to have data processing and data storage from far edge all the way back to the cloud. And I think one of the big things that we're going to have to figure out is by application, how much data needs to be stored where, how much of the processing needs to be done where, the inference done here or here, the retraining or the fine tuning done here or here. So the data is going to be one of the biggest considerations.
Here's an interesting question. I'm not sure, but anyway, it's training versus inference, right? How much of the traffic, and it says data center usage, is now training models versus, running inference for customers?
Training has been probably, I'd say 60 to 70% historically of what's been happening in data centers. We're starting to see inference become a larger part of what we do. But over time, inference is going to be exponentially more pervasive than training.
Yeah.
Right?
And when you talk about training, are you including like all the pre-processing and the data as part of that training usage?
Yes.
I think that's a piece that gets underestimated by a lot of people.
Couldn't agree more. Couldn't agree more. You need to pre-process the data. You need to get the data ready. I mean, just taking raw data and throwing it in a model isn't going to produce you very good things. You need to make sure that you're curating the data, cleaning the data. You have the right data to train the model on, right? If you want the model to be smart, you got to give it the right content to be trained on.
And here's one from somebody who's still back at, obviously loving, the NVIDIA gaming days, but it's, what are the next milestones in, AI dominating games, right? The breakthroughs in Go that we saw, or chess or whatever. What are the next frontiers there?
It's a good question. I don't know the answer. I don't know from a gaming perspective. I haven't given a lot of thought. I know NVIDIA has, but I'm been so myopically focused on the pieces outside of gaming. But it's going to transform everything. I mean, the ability to interact with agents in a game, right? as opposed to just, running your controller. You actually get to interact. It's going to transform games in a big way.
Yeah. Here's a very interesting one. It's like, how do you embrace AI without, alienating your workforce? Can you share some really good examples of organizations that are really successfully integrating AI, without and keeping employees?
So AI is meant to be a tool to help people. There's a phrase that started in the automotive side of things. It was human in the loop, right? So you always want a human in the loop. The AI is there to help the human. You're not going to remove the pilots from the cockpit of an airline, but the AI is going to help them. You're not going to remove the surgeon from doing the surgery, but the AI is going to be there to help them. The most impactful AI implementations today and usage today always has human in the loop. Are there jobs and tasks that AI is going to eventually replace? Absolutely. But what does that do? It opens up more opportunity for humans to focus on other things that are creative for the company.
Yeah. And I mean, I would have thought like NVIDIA is a perfect example. When you get to the stage that you've got, a billion transistors in a unit, that you just physically can't do that with the mental capacity that we have without AI. Okay. How about jobs lost versus opportunity created? What are the jobs that there's just going to be so many more of because of this than the ones that are lost?
Well, it's a really good question. Things like writing software, pretty commonsensical that AI is going to be able to do that. Things like customer service, pretty commonsensical that AI is going to be good at that. Physical AI is really at its forefront. We'll see how good physical AI is, right? Construction or all the things that are happening in the world. I don't know. I think it's too early to say, but I think what's going to happen is you're going to have more time for humans to focus on more productive tasks, whether those are productive for the individual or whether those are productive for the organization.
Yeah,
Right?
and so that begs the question then, I'm sure you get asked this one all the time. As universities, what should we be doing to prepare people for this?
Educating folks on AI. I was meeting with some of the people at University of Washington a couple of months ago, and they were surprised to hear that in Saudi Arabia, AI is mandatory in elementary school curriculum. Right? In the US, we're straining just to get it into university curriculums in many places. The other piece is when people think about AI, they say, well, to get trained on AI, I need to think about it as a computer science problem or a computer science course or a computer science opportunity. And yes, that is absolutely true, but there are many other places where AI is going to require expertise in workforce, right? The applications of the AI, what do you do with it in healthcare or in finance, right? So making this part of
To kind of nail this a little bit more specifically, Matt, what kind, because as you say, we've had AI since the 50s, right? What kind of AI is in an elementary school curriculum?
So they're teaching people about what's possible with AI. They're teaching people with how AI works.
So
But
it's
it's
how to
not just,
create good prompts.
yeah, but it's not just about the science of AI, right? It's not about how do you go build a chat GPT model. It's
Yeah.
how are you going to integrate it into your business, even if you have nothing to do with computer science. How are you going to go build the AI? I mean, if you look at these data centers being built all over the world, if you look at the new power sources, that's going to open up a lot of opportunities for employment and for people that need to be trained. How do you build efficient chillers and data centers? How are you building fission, right? Fission's a big part of AI. How are you going to go educate people on that? So I think it's thinking outside of the box that it's just a computer science.
Yeah, and there's another, related question. I know I've talked to, one of the fastest places that we're seeing reduction in force because of this is in computer programming. So there's a question here about what about the threat to people studying CSE? I was talking to a VP of Microsoft a couple of weeks ago, and almost 60% of the code on GitHub already is machine generated. So there's real worry in kids who are in CSE programs right now. What do you say to them?
Yeah, I make sure that you look at where AI is impacting things. The fact that they're noticing that, the fact that they're tuned to it is really important because you're going to have to make sure that you can tailor your career trajectory, your studies in accordance with where you're going to be able to do things, right? There's going to be plenty of opportunities to go in and manage that. The AI is going to produce this stuff, but it's not just going to be lived and distributed by itself. It's going to need a lot of people to do that. But yes, it will take up a lot of, it'll help quite a bit with software development.
Yeah, and yeah, as you said, you were at the UW. That there are obviously huge concerns here. If you had to say what were the top three things that, say, the Foster School of Business should make sure everybody who walks out the door is able to do in this new world.
Understand where AI is going and the applications for it in the business, right? So if we talk about Foster School focused on business, what are the implications, whether it be the outputs and use cases, whether it be the governance of AI, whether it be the growth of the technology. I think everybody just needs to understand where things are going. They need to understand it's real. I still talk to a lot of people that say that AI is hype. And to me, that's just a foolish thinking. I mean, AI is here. It's going so fast. There's a great paper that was written by one of the founders of OpenAI. It's called Situational Awareness, if anybody's interested. And it's a paper that talks about the people that are in the center of the storm see what's coming. AGI is right around the corner. This stuff is coming very quickly. It's not just writing the haiku or making the picture of a hot air balloon out of a generative AI. It's coming in a big way.
So maybe you could walk us through your day. What are you doing now versus what you were doing 3 years ago that's been radically changed by AI? And if you need a minute to think on that, I can go to the next question.
No, I think at its core is I don't have to convince people anymore. It used to be a lot of selling, a lot of convincing, a lot of marketing. AI is here, it's coming, here's what you need to do. My job and my team's job has changed from the evangelism to the how. People realize, okay, now I know it's real. What do I do now? How do I get started? So it's less of the pushing and more of the helping people get things deployed.
Yeah, well, I was meaning more like from a personal productivity point of view. How has like the management of your time and your calendar or your world changed?
Oh, everything's changed. I mean, I use Perplexity on a regular basis. I use OpenAI on a regular basis. All of the tools that are built into the software, whether it's Microsoft or Salesforce.com or Workday or ServiceNow, right? All of these things, whether you see them or not, Copilot, it's just going to make everything, it's already making everything much easier.
Mm. And so there's a question here about data privacy, security and AI workflows. What are the key things that you're seeing that you said you've gone from, explaining the why to the how? A lot of the initial reservations were, my daughter's in law school, they're not allowed to use AI with cases because they don't have a private, thing. So what are the use cases, or what are you seeing being done to reassure people around security of data?
I think there's a couple things. Number one, making sure that the models are trained before we get into security on the most relevant data. If you have a bunch of crap in your model, crap in, crap out, it's going to provide you bad data, hallucinations when the model has things wrong. If you don't have the right data in there, it's going to miss out and it's not going to know things. So we're very focused now on helping when people are building models, refining models, they're building their AI, that they're as domain specific as possible. If I'm Subaru and I'm building a customer service agent, I want it to be trained on everything Subaru, from the tires to the engine, to all the parts in it. I don't want it to be trained on, how McDonald's does French fries or on the French encyclopedia. That stuff doesn't matter. So it's really keeping it domain specific that the data is there. Confidentiality, that is something that, is going to be more and more important over time. But at the same time, the more we can share data, the faster we're going to see results from artificial intelligence. If we talked about the self-driving cars, it takes all this data to convince the world that you can self-drive a car. If those people shared all of their data, hey, we have this training data, we have this training data, you put it together, So I think we're going to see a fine line between what's confidential, but also what can be shared more generally with each other to help accelerate these models.
Yeah, and there's an interesting question here. It reminds me, there was a celebration for all the UW people here last night for David Baker for winning the Nobel Prize. It was a big university celebration, and the mayor gave him the key to the city, but he read the citation on the Nobel Prize, and it was quite obvious he had no clue what he was reading. So that's what it's going to look like when I read this question. Okay, so it's Cerebras. What do we think about Cerebras inference chips with 900,000 cores, instantaneous inference with 2,000 tokens per second? What are the implications and the new use cases or opportunities that opens up?
Yeah, so Cerberus is one of our competitors building a chip. They are known for wafer scale. They build these very large chips, and they build great chips. But it comes back to the comment I made earlier, right? People that build chips there are many of them, and they're building great chips. We're not building chips. We happen to build chips, but that's not our ultimate goal. It's to build the full solution. So Cerberus is a great company. They build great chips. They don't have the full solution. So I'm not that in tune with them. We don't see them out there as much.
Yeah. And speaking of your chips, like you do build chips, you don't manufacture them. I'm sure there isn't a single conversation where you don't get asked about the Taiwan problem. And basically you're single sourced, right? I mean, you used to use Samsung, but it's mostly TSMC now.
It's mostly been TSMC for all time. We've looked at other options. We have a very strong relationship with TSMC, very strong relationship, but there are some concerns, right? Taiwan situation is always volatile. You guys have probably seen, and if you haven't seen, you will see some of the investments that TSMC is making in the U.S., building new facilities in Arizona and other places. So the more we can distribute the manufacturing and the IP outside of Taiwan, the less concern we'll have. But to build one of these fabs takes a long time and billions of dollars. So we'll continue our relationship with TSMC. We just need to diversify it in other locations.
Last I heard, TSMC was not exactly excited about its US experience to date, right? But there's also still single sourcing parts of the supply chain for semiconductors like ASML or whatever. So we're interdependent anyway.
Absolutely. Absolutely.
I don't think there are any more questions from the audience. So what haven't we asked? What are the things that you see coming down the pipe that we should know about? Or they're just plain cool? I mean, you go to these conferences, you see amazing applications. If you had to tell us of, the three coolest things you've seen done, with this new generation of AI and, multi-threaded processing.
Yeah, it all comes down to agentic. Agentic AI is the big game changer.
Yeah, maybe you could explain that for people, because I'm sure not everybody else, understands the concept.
Yeah. So it's all about having an agent, someone that can reason, someone that can think. And again, that can be embodied in the PC, in your phone. It can be embodied in a robot, but it's a huge sea change from just generation of images, because now you have a reasoning AI agent. You have someone you can talk to, and over time, that's going to get better and better and better. The applications for agentic AI that I'm most excited about, healthcare. I think we're going to see huge strides in our fight against cancer, vaccines, pharmaceutical gains. I couldn't be more excited about what we're going to see in the healthcare space. Self-driving, autonomous vehicles. I've been waiting for the day my kids are of driving age in a short couple of years, and I'm hoping that we'll have autonomous vehicles. I think that's going to be a huge change in the way the world works.
Well, you're in Waymo land. I mean,
yeah, we are in Waymo land. It's amazing to see for those that have not been to. Yeah, you don't have it in Seattle yet, right? It's coming soon.
no idea.
Yeah, it's amazing. And for those that haven't been into San Francisco, these Waymos zooming around and getting better and better. But the implications for self-driving cars, it goes beyond just the driving experience, right? If you have less cars on the road, you need less roads, you need less parking spaces. It's going to transform the world in a big way.
And fewer random humans at the wheel, right?
Absolutely. With road rage.
Yeah. I'm just checking to see if there are any more questions in here. I'm not seeing any more. There is one about, NVIDIA's success in higher ed. You mentioned in New York that there are, a bunch of universities coming together to build, a multi-core system. Have you seen, apart from Saudi Arabia, a great example of where NVIDIA has been successful in higher ed?
University of Florida, Florida school system, we've done quite a bit. Texas, we have some great projects going on with the state of Texas across the university system. As I said, Empire AI in New York is a great example. And I really want to do something bigger with the university in Washington. You guys have the highest concentration of data scientists and AI practitioners on the West Coast, if not the world. And I think there's a huge opportunity for the University of Washington to leap ahead. So I want to do more with you guys. And we've had an offer out for some time to do more and more together. So I'm hoping we can and make sure that Foster and overall UW are leaders in the academia world of AI.
Yeah, there's one here. So we're going to end probably on this one, but what do you tell your kids? What advice do you give them, for what they should be doing, the current generation growing up in this environment?
So number one, I'm giving them access to the right AI tools, right? I want to make sure that they are aware of the AI tools that are available, the safe ones, the ones that they should be using. Teach them where to use it, where not to use it. Teach them the pitfalls of it, and I'll continue to do that as AI evolves.
So I'm your kid. Talk me through that. Where should I be using it? And where should I not be using it?
Homework is probably not a place. Write an essay about this. It's surprising now. Actually, my daughter came home the other day and she said, "Well, the teacher said we could use ChatGPT to write this, as long as we went in and refined it to make it sound better." So I think over time, the definition of where it should and shouldn't be used will be decided not by me as a parent, but by other places. But they shouldn't.
Yeah, and
All over their own. You know. Um, the other piece is just understanding how powerful this is. My daughter and I were talking the other night, and she said, "Well, how is AI going to get so good?" And I explained to her, I said, "Look, you're in fourth grade now. She's 10. And I said, you're learning what I learned 40 years ago, right? You're learning what I learned 40 years ago, and then you're going to learn the same thing that I learned next year, 40 years before that. And your grandparents, I learned the same thing. What if you didn't have to go through that? What if you just learned it once and then you learned more and more and more and more and more? And it really woke her up to, oh my God, these things are going to move quickly. So I think the speed and importance of AI, making them aware of that, where and where not to use the tools are the most important things.
Yeah, and that's exactly where the university is struggling, right? My take in a business school is use every AI tool you can get your hands on, just reference them, right? So where would we be without some doomsday scenario, right? I was lucky enough to interview. There was a book written by Eric Schmidt and Henry Kissinger, and then Craig Mundy at Microsoft that was launched recently, and they talk about how do you protect against the doomsday scenarios, right? The bad actors. How do we do it?
I don't have an answer. I don't think anybody has an answer. I'll tell you, overregulation is as scary as underregulation and bad actors, right? Nuclear, you mentioned fission. Nuclear is probably one of the most powerful things out there. And it was so overregulated, there was a lot of concern around it that it took decades for it to become something that's been taken seriously. We don't want to overregulate AI out of fear, but we don't want to underregulate it. So those regulation guardrails are going to have to come over time. The other thing we have to realize is that AI is out of the bag, right? Every country is doing AI, so we can't regulate on a local basis. We can't say, okay, we can't do AI at this level because maybe somebody else somewhere is doing it. So we need to look at this on a global scale. We need to look at it in a way that, we can do it safely with little regulation and make sure that it's helping us. But are there bad actors, right? Yes. Are there concerns? When we launched the internet, everybody was convinced the world was going to go out of business. We were going to die. When nuclear came out, everybody was going to die. There's always these concerns. I think it's, tempering it and monitoring it over time.
Okay, we can't end on a sour note. What's your greatest hope for the future that's going to be facilitated by this?
I think humanity is going to be able to focus on things of higher value than what we do today. The AIs are going to replace a lot of the mundane tasks. The AIs are going to replace a lot of the things that we're forced to do that really don't provide a lot of value to quality of life. I think quality of life is going to improve, right? We're not going to have to drive anymore. We're not going to have to, do expense reports or pay bills or those sorts of things. It's going to lead to higher quality of life for everybody, whether it's the healthcare side, whether it's the personal side. It's just life's going to be better.
Awesome. Well, Matt, thank you so much for joining us. On behalf of the University of Washington, also on behalf of a shareholder in NVIDIA, we really, really appreciate it, and do persuade the UW to get on the leading edge of this.
Absolutely. Appreciate everybody's time. Thank you very much.
Okay, take care. Thank you.